Hi guys, good evening. So last time we had done with what was the topic we had done last time? We had done the sorting we had done, right? Selection, bubble, and insertion. So today we'll start with one different type of sort. Okay. And that sort would be called as so today I'll do a sorting and then we'll also do some little bit of searching also too. So day 3, I made a package by the name sort. Let me share my screen. Just shout out once you are able to see my screen. Yes, no, maybe. I'll just have a look at the YouTube guys as to how well they have progressed. One sec, just let me see. Have these guys joined on YouTube or not? And how far have they progressed? Yep. And day 3 is live. So people have started joining over here. Okay, YouTube also is active. Let's come back. Just shout out once you are able to see my Eclipse screen, guys. If no, then let me know. See not visible on the chat. Okay. So today is day 3 sorting. Today's sorting technique which I plan to discuss is merge sort. Okay, very interesting sort. It will help you out tremendously in your logic building. Is the paint screen visible? Okay, so if I take an array of let's say 8 numbers, and if I ask you all to sort this using merge sort. So let me write the title over here of today's topic. Merge sort. And we'll see how this sorting technique works. So let me make an array of 8. So I'll take random any 8 numbers. I'll take single digit numbers for the ease. So let's say 9, 6, 4, 5, 1 second, hang on. So 8, 3, 7, and let's say 1. So these are my list of numbers. So whenever we do merge sort, we'll try to split this array into 2 halves in every iteration. Okay. And this are the index of this array, correct? So I'll just Let's take this array a little bit down that we can fit into one screen. So these would be the indexes of that array, starting from 0, 1, 2, 3, 4, 5, 6, and 7. These will be the indexes, right? Now, in every iteration, what we would do is we will split this array into half. So an array of size 8 into half would become 4 and 4. So this 4 aside and this 4 aside. Okay. And now array of 4 into half would become 2, 2. So this 2 and this 2. Like this, we'll have to split this array. And this 2. So in the first cycle, we will keep on only splitting the array into half, half, half. And this. Okay. Till we get individual elements. Now still I have not got individual elements. So I'll again split into half. So 9 and 6. Okay. And 4. And 5. Eight and 3. Okay. And 7 and 1. So keep on splitting this array into until it becomes into single digits. So this would be the first phase of merge sort, the split phase. And now once the splitting is done, then we will start the merging phase. So you have to sort and merge. Later, cursor dancing. Is the cursor going there always? The cursor, I'm trying to cut from here. So now, one. So now once the splitting phase, this was into the splitting phase. Once this phase is done, now we'll start with the merging phase. But while merging, we need to sort and merge. Sort and merge. Okay, so from 4, I got an array of 2 each. From 8, 4 each. From 4, 2, 2. Right? And from 2, 1, 1. This was your splitting phase. Now all you need to do is sort and merge. So 9 and 6. How will I merge them after sorting? Will become 6 and 9. Yep. 6 and 9. So now keep on merging. First sort them. 9, 6 sorted will become 6 and 9. 4, 5 sorted will become 4, 5. 8, 3 sorted will become 3, 8. And 7, 1 will sorted will become 1, 7, right? So now we are into the sort and merge state. So first I was doing on 1, 1 each. So I have merged these two back. 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 Sorted and merged them. And sorted and merged these two. Now what do you think will be the next step? Sort and merge the two arrays. So 6, 9, 4, 5 sorted and merged would be 3, 4, 5, 6, 9. 4, 5, 6, and 9. And 3, 8, 1, 7 sorted and merged would be 1, 3, 1, 3, 7, and 8. Okay, so now I have merged these two into one and merged these two into one. And now merge these array of 4, 4, and that would give me my resultant array. So 4, 5, 6, 9, 1, 3, 7, and 8. Now merge these two arrays. So it will become 1, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9. So this is my resultant array. So how we have achieved this, we'll try to code this. So all you need to understand is, try to understand the first phase of splitting. Try to understand this. You want to really understand merge sort. Try to understand the first phase of splitting and try to understand the last phase of merging. That's all. You can skip all this in between. So if I try to explain y'all these two arrays, so I'll call them as ARR1, ARR2. ARR1 and ARR2. From which index to which index is ARR1 and from which index to which index is ARR2? Yes, you can send the answer in the chat. From which index to which index is ARR1? So if I say 7 and if I calculate the mid of 7 into an integer value, so if I say integer mid equals to the max index, which is 7, okay? Max index divided by 2. The max index is 7. So 7 divided by 2 gives me 3.5. So my mid will be the integer value of 3.5. In integer, we truncate the decimal. So what is my mid now? Mid is 3. So here is my mid. So if I take the first index in a variable and the last index in a variable. So let's say if I take this into the first and if I take this into the last. So what would be the formula for mid? Mid would be first plus last divided by 2. So what is my mid over here? My mid is 3. So directly you can say like this over here. Mid is max index divided by 2. Just take this. So now what is the max index? So my mid is over here. So who can tell me the first array, I'll color code it, the green array, is spanning from which index to which index? And the green, I'll take a different color, which purple. The purple array is spanning from which index to which index? So just understand the first split. That's all. So the first split starts from first and goes till mid. The first split starts from first index and goes till the mid index. And the second split starts from mid plus 1 index and goes till the last. Make sense? Yeah. So even if you understand the first split is more than sufficient. Okay. So let's try to code this. Let's try to code this. So I go to sorting day 3, new, and I make a class merge sort. Okay. The main method in it. So now give me the array. Who has photographic memory? Who can tell me what was the array? Array was 96458. 96458 371. Okay. So I'll sys out this array before merge sort, and it will be arrays dot toString and array name is ARR. Then I'll call a function called merge sort, and then I'll display this array after merge sort. And then I'll display it after merge. So this function is there, not there. Create this function. Okay. Now what do we do over here now in merge sort? Yes, guys. What should be our algorithm when we have to implement merge sort? So in my merge sort, I will have to first split the array. Okay. So if I show you all, this is my array, right? So when I'll call the merge sort, I'll pass three things to it. I'll pass the first index and I'll pass the last index. What would be the last index? The last index would be dot length minus. Okay. So now let me rephrase this now. So now this is my array. This I is my first and this J is my last. Okay. So what would be my mid now? What would be the mid? What would be the mid? Mid would be first plus last divided by 2. Right? So if initially my first was 0, correct? 0 and my last was 7. So considering that, what should be my mid value? Mid value is 3. Now, what should be my first split? What should be my first split? Starting from first index till mid and second should be. Okay. So what I'll do is I'll recursively call the merge sort again. Starting from where? On the same array ARR. Starting from which index? First index. Just understand the first split. The first split starting from which index? First index going till where? So the green array is starting from 0 and ending at mid. So your first index is first and last index is, and then for the second, and I'll just call merge sort again for the same array. Now the first index for the purple array is what? What is the first index of the purple array? 4. 4 is mid plus 1. And the last index is last. Okay. And then what I'll do is I'll merge all this. Okay. I'll merge all of them together by calling the merge function. I'll pass the array. I'll pass the first. I'll pass the mid. And I'll pass the last. So this now create this function. Now just create this function. Let's create this function. Okay, so while you're splitting, all you need to understand is the first split. So I calculate the mid. I've got the last index. So from here, when I call this merge sort function, I pass the entire array. Array comes in ARR. I pass the first index and the last index, right? First index is 0. Last index is the length minus 1. First index comes in first. Last index comes in last. I calculate the mid, which is first plus last divided by 2. And then I do the splitting. So just understand the first split. First array, which is green and purple, is starting from the first index going till mid, and second is from mid plus 1 going till last. First till mid and mid plus 1 till last, and then I'll merge first, mid and last. Array, first, mid and last. Okay. And now when you're merging, you got to understand the last merge. That's all. So I'll just take this aside. I'll take this aside, okay? With the indexes. With the indexes. So because I have passed the first, mid and last. Right? So while merging, I have passed the first, mid and last. So what is in the array? The entire array. What is in mid? What is in first? First has 0, mid has 3, and what is in last? Last has 7. So first has 0, mid has 3, last has 7. Okay. Now what I'll do is, simple concept in this merge sort. I'll put 2 pointers over here. So I'll put a I pointer. Let's make it a bit bolder. So I'll have this too much. This is okay. So I'll have I, which starts at the first index of the left array, and I'll have J, which starts at the first index of the second array. Okay. And I'll make a new array called BRR. This is my new, this in which I'll go to merge. I'll make a new array. And this new array as of now is blank. Okay, so there's nothing in this new array. It is just a fresh array, nothing in it. I'll make a fresh array whose length will be same as the original array ARR. So how will I make a BRR array in the merge function? How do I know this array should be of size 8? So how do I make a array of size 8 over here? So I'll say integer BRR is a new integer of size what? 8 means I want of size 8, right? So I'll say what? Last plus 1. So as this array was of size 8, this also will be of size 8 because I have passed the last index, which is 7. So I'll make an array of size. So this is a fresh array now, BRR. So at which index do I need to place the first number? At 0 index, so I'll call that as K. So now I need to initialize 3 variables, I, J, and K. So where is I starting from? Where is I starting from? Which index? 0. 0 is with this variable. First, so I'll say integer I equals to. Where is J starting from? 4. So how do I initialize J? Mid plus 1. And where is K starting from? 0. Who has 0? First. So I'll initialize these variables. So now I is at first, J is at mid plus 1, and K is at first. Now I'll compare the number at ARR of I with ARR of J. Whichever is smaller will go in BRR of K. So if my ARR of I, okay, ARR of I is less than or equal to ARR of J. Okay, try to understand this. So what happens? So if the number is less, this the value on the left array goes into the BRR. If it is greater, the value on the right array goes into the BRR. So ARR of I, what is ARR of I? 4. Is 4 less than 1? No. So we'll go in else. We'll go in else. So let's reduce the font a little bit. Yeah, makes sense. So if ARR of I, so is 4 less than or equal to 1? No. Then it goes into else, and the element at which index? J index goes into which? BRR of K index. And now I've got the number from here. So whichever number has gone, that index will increment. So J will increment and K will increment because K has to increment. And if it is coming from this array, then what would I write? So if ARR of I is less than ARR of J, then element at the I index would go at BRR of K, and I'll increment the I and I'll increment the K. Okay. So try to understand this. And till when would this happen? Till when would this happen? So what is the boundary? Okay, I'll draw the boundary line. What is the boundary line for I? What is the boundary line for I? And what is the boundary line for J? So this will happen till my I is less than or equal to mid, and my J is less than or equal to last. So till this condition is true, I will keep on copying. I've given an and over there, so both should be true. Okay, now so let me try now. So what is the value of I? 0. What is the value of J? 4. Is
Screen is
0.
feature. Hello.
Hello.
Can you please check students are saying the screen is fish?
Now?
Yeah, now it says.
So is I less than equal to 0? Was the screen visible earlier? Guys? Were you all able to see all this? These guys don't respond. I don't get time to. If the Zoom guys could be a bit more vigilant and alert and informing whether the screen is visible or not. So because I very frequently I switch to YouTube. So the Zoom guys, please take an initiative of letting me know whether you all are able to see my screen or not. Or whatever I'm saying, is it matching with the screen? So I was doing all this. So were you all able to see all this while I was explaining this for the last half an hour? Zoom guys? Yes, no, maybe. Let me check for the YouTube guys. Okay, you all saw till I wrote this, right? Okay, till here it was all good. So I'm sharing my entire screen. See, I really share my entire screen. So till here you all were able to understand. So merging you all understood. It was about the splitting. So in the splitting phase, okay, yeah. Now in the splitting phase, try to understand the last split. If you understand the last split, it's more than sufficient. So last split means I will try to merge these two sorted arrays, right? So whenever you're merging, you're always merging the sorted arrays. So 4, 5, 6, 9 is sorted, 1, 3, 7 is sorted. Now how do you merge two sorted arrays? So to the function I have passed the first, last and mid. So my first array starts from which index? 0. 0 is with first. So that's why I have declared I starts from first. And I made a fresh array BRR. So this BRR is a fresh array I have made. So it's an empty array whose size is same as the original array. So when I pass the last index, this array size is last plus 1, means 7 plus 1, 8. And I've initialized these three variables. First, mid, first, I, j, and k. So I is for the left array, the starting index of the left array. So that starts from 0. 0 is with first. So first goes into I. The second array starting index is j at 4. So mid has 3. So j initialized to mid plus 1. And the third array, which is the blank array, will also start from the 0 index. So k also initialized to first. So I, j, and k. And now I has its boundary. I has to be within this green boundary. So if I crosses 3, I'll terminate the loop. And if j crosses 7, I'll terminate the loop. So my loop is while I is less than equal to mid and j is less than equal to last. Okay. Now whichever is smaller between I and j. So 4 and 1, whichever is smaller, I'll put that in the resultant array. So now I'll check over here. ARR of I, that is 4. Is it less than 1? No, we'll go in else. So I'll put the j index value, that is 1, where at what index? BRR of k over here. And now the next number I need to compare in this array is 3, correct? So I'll increment the j, and the next index where it will go in b will be over here at 1. So I'll increment the k. And now, is my I less than equal to mid and j less than equal to last? Yes, while is true. Now, is 4 less than equal to 3? Yes or no? No. So element of j will go in else, right? So element of j index will go at what? BRR of k. And I'll increment the j and I'll increment the k. Okay. Now again, is first less than mid? Yes, it is I less than mid. And is j less than equal to last? Yes. ARR of I, 4. Is 4 less than equal to 7? Yes. So now this element. So now if it is true, right? So the element at I index will go to BRR of k. So this will come over here. So now I've got it from the left array. I'll increment the I now. I plus plus and k plus plus. Okay. Now, is 1 less than equal to 3? Yes. Is 6 less than equal to 7? Yes. While it's true, come inside. Is 5 less than equal to 7? Yes. So 5 will go at BRR of k because this condition was true. Now I got from the left array, I'll increment the I and I'll increment the K. Now is 2 less than or equal to 3? Yes. Is 6 less than or equal to 7? Yes. Both true, come inside. Element at I is 6. Is it less than element at J 7? Yes. So copy from the left array. So if it is less or equal, copy from the left array, and from wherever you are copying, increment that variable. And K will increment in both the cases. Irrespective it comes from I or J, K will increment. So K is incrementing at both the locations. Now is 3 less than equal to 3? Is 3 less than equal to 3? Yes. Is 6 less than equal to 7? Yes. Is 9 less than equal to 7? Is 9 less than equal to 7? No. So copy from the J. So take from 7 and put it over here. And now J plus plus and K plus. Now is 3 less than equal to 3? Yes. Is 7 less than equal to 7? Yes. 9 less than 8? No. So copy from the J. And now J now has plus plus. Now J has crossed the boundary. Okay. I have to understand this now. And K plus plus. Okay. Now as J has crossed the boundary, is I less than equal to mid? 3 less than equal to 3? That is true. But is 8 has got to 8 index? No. Is 8 less than equal to 7? Now this loop will break. Now once the loop breaks, now what to do? Now whatever array which is left. So if J has crossed the last, means there are few elements in the left array. And if I had crossed the mid, there would be some elements in the right array. So now copy the remaining elements, because as the arrays are sorted, just copy the remaining element into the array now. So what will I do now? I'll check now. If my I would have crossed mid, if my I would have crossed mid, means there would be some elements left in the right array. So whatever elements are there, copy them blindly to the. So I would just say while my J is less than or equal to last, copy all the elements. Okay, what I was doing over here. So how do I copy from the J? This is how I copy from the J. This is how I copy from the J. And if now in this case, now in this case, how we have, now as we have in this case, okay, I'll revisit this logic once again. So now as we have in this case, so this was when I crosses mid first. But what if J crosses the last, then what to do? So I'll write this logic again. So both cases can occur, right? So now if my J crosses last, what to do? If my J crosses the last, then what to do? Means there are some elements in the left array. So left array index is I, and I has to be less than or equal to mid. And the way I was copying from the left array, I'll copy that over here. So I'll remove this. And I will do this. See, why am I using this part? The yellow part, why am I doing this? Why am I doing this? The reason for that is I'll show you all. Okay, I'll just show you all the reason why why I'm doing that. Let me show you all. So data structures you cannot learn without drawing. You have to constantly draw. Guys, one second, just give me a minute. I'll be back. Okay. So the reason I'm showing on the yellow logic is, if this would be the scenario, let's say, if the scenario would be this, wherein one array gets completely exhausted. So if the numbers were, let's say, 3, okay. So if the numbers were 3, and this array would have heavy numbers, okay. Let's say it would have 45, 67, and 91. And this array would have light numbers. So 7, 9, 11, and 15. Because we have to merge two sorted arrays, right? So what would happen over here now? 3 less than 7, 3 would get copied, right? And what would increment? I would increment. And J would be over here. Now, 7 with 45. So, 7 would get copied and J would increment. Now, 9 with 45. 9 would get copied and J would increment. Then 11 with 45. 11 would get copied and J would increment, because from there only I'm getting the numbers. And 15 with 45. 15 would get copied and J would increment, and J would cross its boundary. So if any of the arrays cross their boundary, so if J crosses the boundary means if J becomes greater than last, then directly copy all the elements from I till mid into the array. Directly copy, put a loop and copy 45, 67, and 91 directly into the third array. And vice versa also. What if I would cross mid and J would still be in the center? Then, so for that reason we are running this loop. So if my I crosses mid and J is still there, so run till the end and copy it. So here, who has crossed? J. So I will check. Is I greater than mid? Is I greater than mid? No. So copy all the elements. If the I here goes greater than mid, so is I greater than mid? No, right? So this if is false. But is J greater than last? So what do I have to do? Copy all the elements from I till mid on the left array, from AR of I into the K. So for that reason we are doing this. Okay. Got these two while you have understood these? So let's try to implement this into our program now and see how it works. So you all should have a stamina of writing, understanding these complex code. So what was the first while loop? What was the first while loop? Will tell me. While my, okay, I'll keep on constantly switching to and fro from. See, I'm sharing my screen, okay? So I'll be flipping. So while my I is less than equal to mid and my j is less than equal to start. While my I is less than or equal to mid and my j is less than or equal to the last. Come inside. And what do I check now? If my ARR of I is less than or equal to ARR of j, means the number is in the left array. So copy the number from the left array into the ARR of k. And now as the number has come from the left array, increment the I and increment the k. Okay. If it is not less than or equal to, so it will be greater. So will be in else. So if ARR of I is not less than or equal to, means it is greater. So when it is greater, copy from ARR of j into k and increment the j and k. Okay. Once this while loop terminates, if my I has crossed the mid, then what to do? Means left array is fully copied. Now what needs to be copied? The right array needs to be copied. So what I'll do? While my j is less than or equal to last, how do I copy the j? I copy the j like this. Okay. And if this isn't true, I will check if my j has crossed the last. If j has crossed the last means j array fully copied and I needs to be copied. So while my I is less than equal to mid, copy from I and put it into k, I plus plus k. Make sense? So if I becomes greater than mid means j needs to be copied, and if j becomes greater than last means I needs to be copied till mid. Now all this has been done into which array? All these changes have taken place into which array? BRR. But what am I displaying over here? ARR. So I'll copy all the content of ARR into BRR now. So I'll run a for loop. So I'll run a for loop for integer z equals to, which is the first index, first z less than equal to last and z plus plus. And what will I do? Element from z index goes into my, so I'm copying the z into my, I'm copying all the elements from the BRR array to the ARR, because eventually I want to display which array? I want to display the ARR array. And arrays are called by reference. If I make changes in the function, will reflect everywhere. Yeah, so this should work, I guess. This logic should be, so let's check it out. Before sorting is 9645837 and let's check after sorting what do we get. Okay, I guess we are running into an infinite loop, looks like. We're running into an infinite loop, it looks like. Some iterations are missing. Yes, I guess there's some infinite loop which has occurred somewhere. So mid would be first plus last divided by 2. Merge sort. Again, I will call the same array from first to mid, the same array on mid plus 1 to last, and then we'll call ARR from first to mid to last. Okay. So I'll make a new array BRR of size last plus 1, and then I is first, j is mid plus 1, k is also first, while my I is less than equal to mid and while my j is less than equal to last. If my ARR of I is less than equal to ARR of j, then I element goes into k and I plus plus k plus plus. Else my j element goes into the k, j plus plus k plus plus. Yeah. And if my I crosses the mid and my j's hasn't touched last, I'll copy the j's into k. And if my j has crossed the last, I'll go with I less than equal to mid, I into k, I plus plus k plus plus. Yes. And I'll copy all the elements from first to last into my ARR array. Yeah. So this is perfectly sound logic. Where are we faltering with the logic over here? Mid also is fine. Yes, we finished. And then we call the merge function. The merge function, we are making an array and then everything is going fine. Yes. I is less than equal to mid. Yes, and j less than equal to last. Yes, perfectly fine. And if less than equal to j, I goes into k, increment I and k. Else j goes into k, increment j and k. This while loop finishes and check for the remainder. If I has crossed mid, means j is remaining. So put all of j into. Then I take a for loop. It starts with first, goes till last, and I copy all the elements of DRR back into ARR. Yes, this looks good to me. So where are we struggling? This is going to infinite loop. In line number 17 is causing an infinite loop iteration. So this is where we are calling merge sort on the array first. Okay. We'll have to put a condition. There should always be a condition for a recursion. So we'll put this if my first is less than or equal to last, then do this. So my first should be less than equal to last, then only we will do this. So still there's a problem. Still there is a problem. So this is what we were like in the first. So first is 0, last is 7, less than or equal to yes, calculate the mid and do it. First should be less than. Okay, first should be less than last. See. So my first should be less than last, and this output I've got 9645 8371 1345 678. Makes sense, guys, to you all? So let me push this code to the repo and you all practice this. So let me push this code to the GitHub repo that you guys can practice. Anyone has any confusion can put on the chat. You all wish to git status git add dot git commit -m. It is day 3 and git push. Okay, so yeah, push the code to GitHub. So if anyone has any concerns or queries, can share their screen or can ask me their doubt on the chat. Let me flip to the YouTube guys and see if they have any queries or concerns. Yes. Yeah, I've uploaded the material, Junaid. Yes, we were lagging the base case. So that was the base case for iteration. Explain again if else ij. Okay, so you guys, okay, let me see if I can revisit. See, all you need to understand in merge sort is understand the first split. So did you understand the first split? First split takes place from where to where? So if 0 is my first, if I call 0 as my first, if I call 7 as my last, so the green array starts from 0, goes till mid. So mid is 0, 1, 2, and 3. I'll color code the indexes. So first split, second split will be 4, 5, 6, and 7. So just understand the first split and the last merge. So first split starts from first till the mid plus 1 till the last, and then we keep on merging. So now when I'm merging the array, I pass the entire array first, which is 0, and mid, which is 3, and then 7. So now I'll pass track to the last merge. So here, so this is my left sorted array, right sorted array. Left sorted array, first element is 0, first index is 0. Right sorted array, first element is 4. So I initialize now I to first and j to mid plus 1, and k will go to 0. Okay. And now I'll check whether my number, the minimum number is in the left array or right array. But till when will I check? Till my I doesn't cross the mid, until my j doesn't cross the last. So I put a while loop. And from whichever sorted array I get the lesser number, from if I get from the I, I'll put element at I into BRR, incrementing I and k. Else I'll put on the j, incrementing j and k. If any one pointer completes its iteration, but the second pointer is still remaining, so I will check if I has crossed mid, means this array still is remaining, the right array. So I'll take all the elements of the right array starting from j till the last and put it in the BRR. And if vice versa, if j has completed iteration, I'll take all the elements of I till mid and put it into the BRR. And now all the elements are in the BRR array, but I am displaying the ARR in main. So I'll copy all the elements of first to last into ARR and display it. Got it, guys? Okay, guys. So this was your, so we finished with yesterday we finished day before bubble selection insertion. Today we finished merge. Okay, this much short is more than sufficient for you guys. So just give me a 2-3 minutes reliever, and then we'll start with the next topic, the searching techniques. If anyone has any doubts, can post it on your chat. Zoom guys can also be a bit active on the chat, guys. If you are not able to see my screen, or whatever I'm trying to show and whatever I'm trying to speak is not in sync, you can highlight it very at the early stage only. Yogesh, I'll publish all this code onto the GitHub and share you the link. I've already shared the link with the batch. I'll refresh the link again. Okay. Start checking for I less than equal to mid and j less than equal to start. Just to I plus j less than equal to mid plus last. Then in first while itself, we put condition for left and right sub array to be empty. I plus j less than equal to mid plus last. What is the value of I in the first iteration? 0. J is 4. 0 plus 4 is 4. 4 is less than equal to 4 plus 7. That is 11. 4 is less than 11. Okay, so mid plus last is 11. So index is whose sum is less than equal to 11. So 0 plus 4 less than 11. 1 plus 5 is less than 11. 4 plus 6 also is less than 11. Yeah. Yes, yes. Try that, yes. Yeah, you can try, yes. Try implementing it, see if it's working. Should work, I guess. Okay. So I guess the concept of is pretty much clear, right? So if you want to do the fine tuning, what we can do is, if you all want to make it more, so here instead of writing these lines extra I plus plus k plus plus, you could have done it right over here, post increment, right? So take the value and then increment it. So then I'll comment out. So it's up to you, whichever version you want to use. I will not delete it. So k plus plus j plus plus. So comment this out. So this one single line you can do that. Similarly over here, k plus plus. This is post increment, right? So after fetching the value, you are incrementing or decrementing. And similarly over here, k plus plus and I plus plus. So you can comment out this. Okay. So there should not be any problem with the execution. If I right click and run this, it will still give me the same output. Okay. Nice. Frequently switching between the YouTube to read their chats. All good. GitHub link, Junaid, I shared it with you last time. Let me refresh the link. Let me publish the code once again today. Yeah, I've published the code. So let me just refresh. You can use the same link, Junaid. Just go to day 3. Are you able to see the code? DSA Mastery with Java. Okay. Feedback link, Siha. Amar sir will share. Amar sir, students are asking for some feedback link. If there any link for feedback, please share it with them. Attendance and all that, sir will share. Okay, I've shared you all the GitHub repo. Okay. So now let's try to switch to the next chapter. ARR of Z. Why is it taken? Vignesh. Vignesh, all the changes which has happened in the function has happened in the BRR array. I've copied everything into the BRR. Okay. But I'm displaying the output where in the main method, and I'm displaying the ARR array. An array is called by reference. Means if you make changes in an array at some other function, it will reflect in the original array. So then what I'm doing is I'm copying all the changes which I made in the BRR array back to the ARR array. So now my ARR array is modified over here. So if the array is modified in this function, it will affect on the original array also. When I display it over here, it will display the sorted BRR array. Because all of BRR has been copied into ARR. That was the reason. Okay, the reason was call by reference. See, call by value, call by reference, we should know. I'll give you a demo. Okay, call by value. So your simple data types, integer, character, floats are called by value. So what happens in call by value is a copy of the data is sent to the function, not the original data. So in call by value, a copy of the data is sent. Okay, like when you see those action movies, so the main actor, he doesn't do his stunts. His stunts are done by a duplicate. We call a body double or some stunt man. He is doing the stunts. The actor himself is not doing his stunts. So if God forbid any injury happens while doing the stunt, who is injured? The actor or the body double, the stunt man? The stunt man is injured, right? So because a duplicate was working. So similarly in call by value, when I pass the data, so it is received by a duplicate variable. So if I have integer I equal to 10, so this is my integer I. And if I pass it to a function, so if I have integer I equal to 10, then I call a test function. So I call a test function and pass this I. Okay, before passing, I display the I. What would be the answer? Answer would be 10. And I pass it to the test function. So the test function will receive this I. Let's say it takes it into B. Okay, so let me take A and B then. Will take A and B. Okay. The diagram can make sense. So I say integer a is 10, and I say test, and I pass a. Before passing, I display the a, and after passing also, I will display the a. Now this a is coming to b. So what does b contain? B also contains 10. Now a and b are two different variables. The reason of that is, the proof of that is, a is pointing at address 1000 and b is at address 2000. So they are two different addresses. I am displaying my paint screen, guys. Are you all able to see my paint screen? Yeah, so nice, good one. Zoom, guys. So if you all feel that whatever I am showing and explaining is not in sync, please highlight it to me. Okay, so now it is visible. Yeah, I just had to flip between the screen, so it got stuck. So now A and B. A is at address 1000, B is at address 2000. So when I pass this B to the test function, B is a copy of A. So if I display B now, what would be the output? Output would be 10. If I modify B, B equals to 99. What is modifying? The copy is modifying. So B becomes 99, the copy gets modified. And then if I go and display the B again, so what would be the output? 99. And after the function returns, I display A. What do you think will be the output? When I before function call, A was still 10. And after the function call also, A will again be still 10. So your primitive types, your primitive data types such as integer, character, float, double, boolean, okay, byte, all that. Those are all passed by call by value. So let me show you all a demo over here. So let me come to Eclipse and show you, okay? So here I'm taking integer a, value is 10. I display the value. Okay, I display a. Then I pass it to the test function, the a. And then after that also I display the a. Now I'll make the test function. In the test function also I will display the a twice. And I will modify the a also 99. Let's say I take a into the variable b. Okay, you can take in the same variable also, or you can take in different variable. Should not be a problem. So now who can tell me what should be the, or what would be the output of this code? Who can tell me? Okay, I modified the a to b over here. Okay, tell me when I run this code. When I run this code, what should be the output? Who will tell me? Who will tell me? Able to you, all right? Please send in your answers over the chat. What should be the output of this code? Let me check this code in chat. I doubt this code will go in chat. I'll still try. Yeah, I've shared the code. Feeding the number of characters. So I'll just, in the end, I've just given a, in the end, I've just written some dummy code. I am displaying it 4 times, Junaid. I am displaying 4 printouts. I am displaying 4 print statements. 1, 2, 3, 4. So I expect 4 outputs, right? Yes, Lakshman, absolutely correct. 10, 10, 99, 10. A is 10, B is 99. Yeah, so but I'm asking when. See, are you able to see my screen? Okay. So now, if I run this code, the output will be first, this will be executed. So this will give me 10. So first output will be 10. Then the function is called. Now I go to B. B has 10. Second output will be 10. Now B gets modified. So third output would be 99 because B has modified. And then after function call, A is same because the changes has happened on the duplicate. So 4 still remains 10. So output will be 10, 10, 99, 10. I save this and I run and check it. It will be 10, 10, 99, 10. So your primitive types are passed by call by value. So the copy of that data has been passed, not the original. But your arrays and objects are passed as call by reference. Call by reference. So the same example if I take, but with regards to an array now. I this out. Press this out. ARR of 0 and ARR of 0. And to the test, I pass the entire ARR. It comes over here, it receives the ARR and BRR. And now, if I come here and display BRR of 0, and then I say BRR of 0 equals to 99, and then I again display BRR. Now, who can tell me what would be the output? Arrays are passed by call by reference. Okay, arrays are passed by reference. Vignesh, send me all the output in one line. You can use, I guess, shift enter to hit a new line, I guess. Shift enter or control enter. I guess shift enter. Yeah, Vignesh, use shift enter to enter a new line. So you can send all your answer into one chat like this. Shift enter. So what happens in call by reference is this is my array. Ten, 10, 99, 10. I doubt Vignesh. Let's check it out. 10, 20, and 99. Okay. This is address is 1000. Who's pointing to this array? ARR. When I pass this array to a function, it is received by BRR. So BRR will also point to the original array, the same address, because it is passed by reference. So if BRR modifies the content of the array, so BRR of 0, if I make it 99, will it also change for ARR? Yes or no? Okay, so this is called call by reference. So if any value changes at a particular function, it will impact the original. So now I have 4 printouts. So who will tell me is the first printout, second print, third print, and fourth print. So I want the answer like this. So I want the answer like this. that first print 10, second print 20, third print 99, fourth print 10. So send the answer in this format. First print how much? So first print by default is 10. Second print also are not modified is 10. Third print I have changed the modification, so 99. Now what is the fourth print answer? The changes have happened in the function, but will it also impact the original? Yes, in call by reference, original also is impacted. So answer will be 10, 10, 99, 99. Yes, that is what I was expecting. Let's check the online guys. No, yes, 10, 10, 99, 99. Krish, 10, 10. No, Arshdeep. If you are using call by reference, the original also will be changed. So it will be 10, 10, 99, 99. It is not based on what is default. It is based on what type of data you're passing. Yes. If you're passing primitive type data members, then it is by default taken as call by value. And if you're passing any array or any object, then by default it is taken as call by reference. So depending on the type of data you pass, that dictates the default. Am I understood? Yes, yes. Okay, so let's check. Okay, people have sent in the answers. And now let me go and run this code and check. So are you all able to see my screen, programming screen? Yes, Eclipse people are visible. Yes, no, maybe. So now let's check and run this and check. Run as Java application. So see 10, 10, 99, 99 because you are passing an array and array is called by reference. Okay. So now I would want to start with searching. Okay, now we have around 20 minutes we have. If we start with the next topic, or if we can cover any other topic or any other type of search, I'm sorting, I'm thinking. Okay, let's start with the searching. So searching, there are two types. Amar sir, if there's any feedback form, you can share that also with the students. Some of the students were asking on the YouTube chat. Searching. So what are the two types of searching we have? Linear and binary. Okay, I hope those who have studied data structures or who have studied programming should have a fair idea as to the types of search. Now, what is the difference between them? This search is slow and this search is very fast. First difference is. Second is this search is suitable for small data. So data is of small size. Okay, array is of small size 10, 20. Then maybe linear search 50, 100. Then linear search might be suitable to some extent. But if your data is voluminous, thousands and lakhs and millions and billions data you have, then linear search will be very slow. So this is suitable for large data. So if your data set is large, okay, this works in time complexity. I just now write TN. Time complexity of O of n means maximum number of comparison will be equal to the length of the data. So if my array size is 5, max to max, I will have 5 comparisons. So that's why it is slow. So if the array size is 10,000, then I might have to make 10,000 comparisons to search for the data, which would be very slow. But here in your binary search, it works in time complexity of logarithmic time complex, log of n, okay, and log to the base 2. Okay. Works in the logarithmic time complexity and log to the base 2. So how does log to the base 2 work, guys? So if I have 1000, what is log 1000 to the base 2? Who can tell me? And what is log 1000 to the base 10? So in the log, you should know what the base means. Can anyone tell me? So log 1000 to the base 2 is you take the number, whatever you want the log of, and you recursively keep on dividing it by 2 till you get the number 1. So 1000. Okay, so let me open an Excel sheet. Maybe that would help you all understand it better. Okay. So if I take 1000 and recursively keep on dividing by 2, I'll have 500. I'll just keep a count of the divisions, okay? First divide and take this in divide by 2 will give me 250. Divide by 2 will give me 125. Divide by 2 will give me 62, and there will be some carry of 0.5. Divide by 2 will give me 31. Divide by 2 will give me 15, and again a carry of 0.5. Then again divide by 2 will give me 7, and a carry of again 0.5. Divide by 2 will give me 3, and again a carry of 0.5. Divide by 2 will give me 1, and again a carry of 0.5. So how many times did it divide to reach the number 1? 10. So 1000. So log of 1000 to the base 2 is equal to 10. Okay, sorry. Is equal to 10. And then if you combine these together, should give you 10.23, something like that, or some number, right? So that was to the base 2. So what would be for the base 10 now? Same logic. Take the number and recursively divide by 10 till you get 1. This is pretty straightforward. Log of 1000 to the base 10 is equal to 3. So what do I mean by logarithmic time complexity is, if I have 1000 numbers, an array of size 1000, if I have a array or a list of size 1000, to search for a particular number or particular data in this array of size 1000, if I adopt linear search, worst case, I will make 1000 comparisons. That is the primitive operation for searching is comparison. So the primitive operation, the fundamental operation will be carried out worst case. Okay, big O always gives the worst case. So in the worst case, it will be carried out 1000 comparison, because it will start comparing on the first and it will keep on comparing in the last linearly, one by one by one by one by, it will keep on comparing. Okay, and the same array size, if it is of 1000, and if I use binary search, then it will give me a time complexity of worst case log of 1000 to the base 2. That is max to max 11. Okay, I'll just round up the 10.23 into a 11. So in worst case, in worst to worst case, I can search for that number and come to a conclusion if it is found or if it is not found in merely 11 comparisons, merely 11 primitive operations. So in 11 comparisons, worst to worst case, if the data size is 1000, I can conclude whether the number is found or not found. So where 11,000 comparison, where 10,000, 1000 comparison, and where 11 comparison. So it's 99.9% comparatively faster compared to your linear search. And as the data keeps on growing, it will, so as the data keeps on growing, this will become slow. As the data goes on growing, this becomes faster. Okay. So this is how you will explain the time complexity. So this works in time complexity of O of n, time complexity of log n. I hope I have explained the time complexity clearly. Okay. Then best case. Okay. Best case, if the number is at the start, you will get the number faster. So if the number is at the start of the list. So the number at the start of the list, best case it will perform. So linear search will perform best when your what you are searching for is at the nearer, at the starting end. And this will perform best when the data is at the middle of the list. Okay. Algorithm which uses, so this just uses brute force algorithm. Okay, you can call it as brute force algorithm because it is not using any technique, just comparing. So like a layman, okay, like a layman would do, just comparing each element with the other till it is found. So it is using brute force algorithm. Okay, but here we are using divide and conquer because we are splitting the data into, and then we are conquering. Okay, so this uses divide and conquer algorithm. Okay, okay, so these were all the advantages in the favor of, these were all the advantages in the favor of binary search. Okay, there's one limitation which the binary search has. Okay, this one limitation, I would not call a disadvantage, I'll call a limitation, that data must be sorted. Data must be sorted. So whatever you are doing, data must be sorted. So if the data is unsorted, you cannot run binary search. So binary search prerequisite is data has to be sorted. One second. So this is a limitation with binary search, that the data must be sorted. So if the data is not sorted, then we cannot run binary search. And here there is no prerequisite. For linear search, no prerequisite. Data may not be, so the data is not sorted, you can still run your linear search. Okay. So just try to, okay, I'll save this document also, guys, as people were selling tools, document all this. I'll just save them so that if I have to share it with you all, I can share it. Okay. So I'll make a different searching, and I'll say types of search. Sharing all this, and I'll publish it to GitHub. Okay. So let me just give me a second. I'll publish all this data onto the GitHub. Whatever we have done today and all the diagrams I have done. Let me share. Let me. The merge sort diagram, I guess, has become totally convoluted, very confusing for you guys, I guess. I doubt anybody will understand. Those who have attended the session, they might understand something. But if I share this to some new person, I doubt anybody will understand. So, but you guys can benefit from this. So I'll maybe save this also. Okay. If you'll have anything else, please post on the comments. So accordingly, I'll try to. Let me push all these code onto the GitHub. Last 10 minutes, I'll keep for your doubt clearance and whatever queries you all are having while practicing, whatever questions you all are solving and you all are struggling, we'll keep for those Q&A sessions we will keep in the last. Okay, and I'll just publish all my code to the GitHub now. Yes, Zoom guys or YouTube guys. Thanks, Junaid. Yeah, tomorrow we'll start with the implementation. Yes, as Yash has mentioned, tomorrow we'll try to do the implementation and various use cases of the two types of searching, and we'll try to implement them. Yeah, O of n would O of 1 would be the best case for your binary search. Yeah, best case would be 1 for both of them, because if the number is at the middle, so the best case for both of them would be O of 1. Okay, the time complexity of the best case for both of them would be O of 1. So if the number is at the first position, if the number you are searching for is at the first position, okay? This is when the number is at, when the data is at first position. So that would work very fast. Okay. Let's put it over here. So in best case, the time complexity, and here also time complexity would be O of n also, when the data is at the middle position. So when the data is exactly at the mid position, you can get it into one iteration only. Yeah, correct. So people are interacting, people are giving their feedback. I'm including those feedbacks in the documentation. If I missed out any point, you guys can always share. Okay. So um, questions for merge sort. He will just ask you like, I had taken an interview. So in that interview, I had asked that if, okay, I'll just show you what I had asked. So not required with, so I just asked this, that in the second iteration, what would be the condition of the array? So let me share my screen. So one of the candidates, I had given a nested for loop, and I had asked that in the second iteration, what would be the value of the array? So this was the first iteration. So second iteration, I was asking him that you just iterate me and show it to me how the iteration will work in case of bubble sort. So with a pen and pencil, I had asked him to draw the iterations. So like this, they might ask you in searching and sorting, that how would the iteration internally run. So that's why I explain you all with the diagram as well as with the code. So this is a simple example. Merge sort, they might ask as to how the first splitting is done. So if with regards to merge sort, the examiner asks, so he will say that if this is an array, what would be the first splitting? So you will say I will split the first from 0 to mid and the from mid plus 1 till the last. So like this, such questions they can create in the interview and ask. Yeah, Junaid, this should help you all substantially in your interview clearance. See, we'll try to clear as many use cases which we can. So I have lots of questions I've prepared for arrays, for strings, for your stacks, queues, hash maps. Hash map is very, very, very critical. So I would want to spend a lot of time with hash map and strings in particular. So I'll try my best to cover a variety of topics. So they should definitely give you all a boost in your level of confidence. So when you guys will see the question or lead code, you all will not be alien or strangers to those sort of questions, because of that difficulty level questions we have already covered in these sessions. So after 15 days, you will see a rise in your level of confidence that these sort of questions we've already covered. But I would want you all to practice also, guys. So that's why I give time in between after each program for y'all, that y'all can practice. If anybody is struggling with anything, can share it with me and I can refactor the code. And so those who are practicing doing pair programming with me, whatever program I am doing, maybe simultaneously, if not simultaneously, then after the session, watching the recordings, you guys are practicing, then I can guarantee that DSA should be very easy for you all, and DSA questions should not be challenging. Yeah, I'll try to revisit recursion once. Sunil. I'll try to. Yeah, yes, we'll try to do hash map, but when we reach to that point. So as of now, we are doing searching, sorting. Then I have some questions planned for strings. So maybe I'll combine hash map when I'm solving strings, because when we are solving questions on string, like which is the first non-repeating character, which is the first repeating character, what are anagram strings, what is palindrome strings. So if we come to that type of questions, we'll surely need hash map. Okay. So those who are doing practicing simultaneously with me will surely benefit. and you can be in communication over the chat. I would request Zoom guys to be a bit more active on the chat because I've flipped to the YouTube very less. Comparatively, I'm most because I'm sharing from Zoom, no? So Zoom chats immediately pops up. I'm only reading the YouTube chats when I flip to the YouTube screen. So if Zoom guys can be a bit more vigilant, and if they see that whatever I'm speaking and whatever I'm sharing is not in sync, immediately bring it up to my notice. Yeah, I guess so. We are nearing today's session. I have pushed all the code for today onto the repo. I'll share the repo link once again. So those who have not got it, I'll share it across to everyone. I'll share it across to the chat on Zoom also, and I'll share it across the chat to the YouTube guys also. Okay. Okay, then I'll see you all tomorrow at sharp 7. Amar sir, do you need to make any announcements or
No, sir, all good.
notice you want to give them?
No, I shared the attendance thing, so I hope everybody mark the
Yeah,
attendance. If
I
not,
hope you mark the attendance.
yes.
Okay, sir, then I'll see you all tomorrow at sharp 7.
Yeah, sure. Thank you, sir. Thank
Bye,
you,
Guru.
students. Okay, chalo. So, dear students, I hope everybody mark their attendance. If yes, then do wind up for the day, and we'll see you on tomorrow.